Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 9.2, factoring out the GCF. Remember, recently I've been telling you that we are going to bring our polynomials back to their original pieces, their factors, from what we were doing when we were distributing and doing double distribution. This is the first step. It's called GCF. The very first question you should ask yourself when factoring is there anything in common among all the term or all the factors, really? Okay. If you answer yes to this question, the next step is to find the greatest common factor. Before factoring binomials and trinomials, let's find the GCF of the following monomials. Well, what is the greatest common factor then? It's going to be the biggest number or variable, or it can be both. It could be a number and a variable, or combination, between two or more factors. Okay, you'll see what I'm talking about here in 1 second. A factor, or in order to factor, we're going to pull out the GCF when pulling out the GCF, we will divide all the terms by the GCF. When I get done, what it's going to look like, it's going to be the GCF times what's left over from one term plus or minus what's left over from another term, and if you had another term on top of that, it would be what's left over from that term as well. So let's go ahead and find the greatest common factor between a few different sets, okay? So what I'm going to do is I'm going to make a factor tree of 42 and 60. So if I make a factor tree of 42, I have 6 times 7. 6 can be broken into 2 times 3. What I want you to realize when you're making a factor tree is I'm trying to find the largest number that they have in common. Okay? So if I have 60, that can be broken into 6 times 10. Well, 6 can be broken into 2 times 3, and 10 can be broken into 2 times 5. I don't really want to get to that bottom line unless I absolutely have to. So what I'm going to do is circle anything that they share. Well, before I even went and broke up the 6 and the 6 and the 10, I could have said they shared the 6, so I would not have had to go any further. Sometimes you will have to go farther, sometimes you will not. So it would be the 6, and then I have 7 and 10. I can't break up 7 any further, so that means that my 10 can stay where it is. So my GCF in this case would just be the 6. Okay? Between 16, 24, and 48. Well, 16 can be broken into 2 times 8. 24 can be broken into 8 times 3. And 48 can be broken into 8 times 6. So if I have something in common right now, I will go ahead and circle it. So the 8 is in common. I only want to use the common term if it's common all the way through. So I could break 6 up into 2 and 3, and that would share with this 6 and this 2. The 2 would be shared. The 6 could be shared with the 3 as well. But since it's not shared in all 3 of the numbers, then I will not consider that as part of my GCF. So my GCF between all 3 numbers is going to be 8. Okay. For number 3, I need to break this up into numbers and into variables. So 18 I can break into, well, this can be 3 times 6 times A times B times C. And 54 can be broken into 18 times 3 times A times B times B. What you're going to notice here is I actually could use the 18 as what it shared. So I would not have had to break this into 3 and 6. It could just be 18 times A times B times C. I'm also going to share an A, and I'm also going to share a B. Okay? So my GCF in this case would be 18AB. All right? Let's see how this works when I actually have binomials and trinomials. Okay? Or actually, I'll just binomials in this case. So I need to make a factor tree for everything. So I'm going to make a factor tree of 5a squared, which would be 5 times a times a. Then I'll make a factor tree of 15, which is 5 times 3. I'm going to circle what they share. So they share the 5. So my GCF is going to be 5. I have the 5 outside. Now I need to make a set of parentheses. So what's left from my 5a squared is the a times a, which is a squared. I'm going to keep the sign, so minus. What's left from the 15 is just 3. So when I take out a GCF, it will be 5 times a squared minus 3. What you'll notice if you do this correctly is if I multiply and distribute this back in, 5 times a squared is 5a squared. 5 times negative 3 is negative 15. That will take you back up to the top. You don't have to do that every single time. I just wanted to show you that if you do it correctly, then when you distribute the number or your GCF back in, you'll get to the original problem. Okay? On to number 2, let's make a factor tree of 7x. Well, 7 times x. Factor tree of 49 would be 7 times 7. So they only share one 7. So it'll be 7 times what's left from 7x is just x. Keep my sign, which was positive. What's left from 49 is just 7. Okay? On to problem 3. Let's make a factor tree. It'll be 2 times y. 6 can be broken into 2 times 3. Then I have times x times y. So they're going to share a 2. They're also going to share a y. So to take out my GCF, it would be 2y times. What is left from 2y? Well, since I'm only using division, I can never get this back to 0, even if I divide by the same number. What you need to think about here is I'm taking 2y and dividing by 2y. Well, that's going to get me 1. So what's left here is 1. Okay? Use the same sign. What's left from 6xy is 3x. And I will be done. All right? Let's go on to problem number 4. 81, you got to think about the factors of 81. What multiplies to get me to 81? What also can multiply to get me to 36? If you think about that long enough, you'll end up with 9 times 9 for 81. You'll end up with 9 times 4 for 36. Then I have x and y with my 36. Circle what they share. Well, they share a 9. So the 9 is my GCF. What's left from 81 is just 9. Keep my same sign. Then I have 4xy left over. Okay. On to problem number 5. Well, 81 and 48 are both divisible by a similar number, the same number. This one I might have to work my factor tree a little farther than I normally would. So let's look at 9 times 9 times r. Well, 9 can be broken into 3 times 3. 9 can be broken into 3 times 3. So I'm not going to be using these 9s now. Okay? 48 can be broken into, let's divide it by 2. So 2 times, what would that be, 24? Well, I can think of 24 can be broken into 6 times 4. 6 can be broken into 2 times 3. And 4 can be broken into 2 times 2. Notice that I took this as far as I possibly could go. Anytime that I branch off a number, I'm not going to use it anymore. So I branched off a 24, so I won't use that anymore. I branched off 6, so I won't use that anymore. And I branched off 4, so I won't use that anymore. Let's circle anything that is shared. The only number that is shared is going to be this 3. Okay? So I also, though, have times r and times s, so my r is also going to be a shared term. My GCF is 3r. Now let's figure out what's left over. Well, I have 3 times 3 left over from 81. That's going to get me 27. I'm going to use the same sign, plus. What's left over from 48? Well, I have this 2, a 2, a 2, and a 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. I also have my s. So I have now successfully factored that term, or that binomial. Okay? Or taking out my GCF to factor, I should say. Let's make a factor tree of xy squared. It's x times y times y. Then I have x times y. So they share an x and a y. So my GCF is xy. What's left over from xy squared is just y. What is left over from xy? Well, I took xy divided by xy. That's going to equal 1. So plus 1. Okay? Let's go ahead and move on to the back. I want you to try some of these problems on your own, but I want to show you something from problem 11. So you guys are going to try 7, 8, 9, and 10 on your own. Bring them with you tomorrow. We can talk about them. But number 11, let's look at that real quick. Let's make our factor tree. If I make a factor tree, don't write all this down. Just pay attention real quick. I want to show you a little trick that I use so I don't have to write nearly as much. So 2 times d times d times e times, times e times e. Okay, that's my factor tree for 2d to the second, e to the second. Now my factor tree for 8d to the sixth, e to the sixth would be 2 times, since I'm only going to have a 2 on this side, I am going to go ahead and keep my 8 broken into 2 times 4. Since I know I'm only going to have one 2 that is shared, I'm going to leave that other number as 4. I'm not going to break up 4 into 2 times 2. Now the d, 1, 2, 3, 4, 5, 6, e, 1, 2, 3, 4, 5, 6. I don't really want to have to make a factor tree that is that long in order to find my GCF. So what I'm going to do is look and see if there's a certain number of d's that they're going to share before I make my factor tree. If you look at 2d squared e squared, you'll notice that I'm going to have 2 d's, which means that I'm going to take 2 of these d's away as my GCF. So instead of writing this as d times d times d times d times d times d, what if I rewrote it as times d squared? Well, how many d's are left over from d to the sixth? There would be 4 of them. So I could break it up as d squared and d to the fourth. Same thing goes with my e's. I know there's only going to be, I know there's only going to be 2 e's. So what if I rewrote e to the sixth as times e squared times e to the fourth? You can go ahead and write that down now because that's the way I like to break it up. If you need to write them completely out, that is fine. But over here also I could write this as d squared and e squared because I know that I'm going to share the d squared and the e squared. I'm going to circle everything that's shared now. So 2 d squared e squared. What's left over from 2d squared e squared? Well, I have 2d squared e squared over 2d squared e squared, which means I'm going to be left with 1. I'm going to keep my sign, so minus. I have 4 d to the fourth, e to the fourth left, so 4 d to the fourth, e to the fourth, and I am done. Okay? Go ahead and try 7, 8, 9, and 10 on your own. When you come in tomorrow, we will talk about those and see how you did on them. Otherwise, that is the end of our video. Remember that the GCF is the largest number that all of the terms in our polynomial will share. When I take out the GCF, I'm going to take each term and divide by my GCF. When I finish, I'm going to write my new polynomial as the GCF times what is left over from all of the terms. If you have any questions over this stuff, please make sure you come in and see me. Otherwise, thank you very much for watching the video, and have a great day.